Let's review. By using data from seismic and other sources that geologists and geoscientists have acquired, they process it by generating two-dimensional charts, graphs, and surveys, and by building three-dimensional models to replicate the subsurface, giving them a clearer picture of what is below. From these charts, graphs, surveys, and models, the team, made up of petroleum geoscientists and petroleum engineers, will then begin the arduous task of interpreting what is there so that they can decide where to drill their first wildcat. Now it is time to put all of our theories into practice. Knowing that 3 out of 4 wildcat wells are dry, the team must now put all of their knowledge, information, and their experience to the test. Here is an example of a new field. Let's look at how a team of geoscientists and petroleum engineers might drill this field based on the seismic information that they got in data acquisition and the information they processed in data processing. Lastly, they have identified the exact location to drill using their skills of interpretation. First, the team has decided to drill their first well here into what the data says is an anticline. They drill the first well and discover that the anticline is a salt dome. There is no oil in salt domes, but they know from past experience that oil can sometimes be trapped along the outer rim of a salt dome. Gambling that this salt dome might have such a trap, the geoscientists and petroleum engineers recommended that a second well be drilled further out along where they calculate the rim of the salt dome is, hoping to locate a trap. They find oil. Continuing to exploit their knowledge about salt domes, they recommended that a third well be drilled on the opposite side. Again, they find oil. By now, they have identified a reservoir rock, so they move out further and recommend that a fourth well be drilled here along a fault in the reservoir rock, knowing that faults are excellent formations for creating traps. This time, though, they do not find oil. They have drilled a dry hole. In reviewing the seismic data that now includes actual data from drilling the 4 wells, they recommended that a fifth well be drilled on the other side of the fault structure. Oil deposits are found. As you can see, this is an example of an ever-evolving drilling program that changes as the team gets more information. Each well the team drills gives them real data about the zones of rock and their formations as they drill downward. They continually update their data and refine their models to improve their chances of striking more oil. Let's review. In finding the next oil field, our startup target is potentially the entire world. We look first on the surface and then into the subsurface. At the surface, we look for sedimentary basins and use the knowledge we know about rock properties to narrow down our choices. We look for oil seeps, we study rock outcrops, and we use the process of elimination. In the subsurface, we rely on tools like the gravity meter and the magnetic meter. Our objective, of course, is to find a promising location to study further. Once we've found sedimentary basins, we then conduct seismic surveys to identify structures that might contain oil. In phase 1 of doing a seismic survey, called data acquisition, we get the information. In phase 2, called data processing, we convert the information into charts and maps so that in phase 3, data interpretation, the geoscientist and petroleum engineer can help us pinpoint the exact location of where to drill the first wildcat well. In this stage, they calculate if there will be sufficient petroleum for further investment. For those answers, we have more tests ahead and more decisions to make. Those will be topics of upcoming lectures.